of the Mathematics 1. Today our topic is partial derivative application as tangent plane and normal line. Now start from the topic. What is a tangent plane and normal line? First, let P as any point on the surface of f of xy z equal to 0 or z equal to f of xy for the 3-dimension or 2-dimension, and let Q be any other point on it. Then take any curve of the surface joining Q to P. As Q tends to P going to the curve, then PQ tends to a definite straight line. This straight line is called tangent line and surface at P. Since different curves can be obtained from the joining with the Q to P, different tangent lines are obtained at P. All these tangent lines in a plane called the tangent plane to the surface at P. Now, tangent plane and normal line equation as P x0 y0 z0 to the surface f of xyz equal to 0 is given by x minus x0 del f by del x at point P plus y minus y0 del f by del y at point P plus z minus z0 del f by del z at a point P equal to 0. In that through the P perpendicular to the plane is called normal to the surface at P. The equation of the normal line to the surface P are given by x minus x0 upon del f by del x at the point P equal to y minus y0 del f by del y at a point P equal to z minus z0 upon del f by del z at a point P. Now we are taking example. Find the equation of the tangent plane and normal line to the surface. As a function we take 2x square plus y plus 2z equal to 3, where point P equal to 2, 1 and minus 3 with respect to x, y, z. So solution is we taking function 2x square plus y plus 2z minus 3. We taking 3 as a left side. P x0 y0 z0, that is a point 2, 1 and minus 3. Now we have to differentiate function with respect to x, y and z and put the value of point. Now first we differentiate function with respect to x. Del f by del x equal to 4x. So del f by del x at a point P equal to 8 because of x equal to 2. Del f by del y equal to 1. Del f by del y at a point P equal to 1. Del f by del z equal to 2. So at a point del f by del z equal to 2. Now the equation of the tangent line is given by x minus x0 del f by del x at a point P, y minus y0 del f by del y at a point P, z minus z0 del f by del z at a point P equal to 0. What is x0? 2, y0 1, z0 3 respectively, and we get the value del f by del x at point P, it is 8, del f by del y at a point P, it is 1, and del f by del z at a point P is 2. Put all the value in this equation, we get 8x minus 16 plus y minus 1 plus 2z plus 6. We solve this, we get 8x plus y plus 2z minus 11. So 8x plus y plus 2z equal to 11 is a tangent plane of this equation. Now for the normal line, x minus x0 upon del f by del x at a point P equal to y minus y0 del f by del y at a point P equal to z minus z0 del f by del z at a point P. What is x0 y0 z0? It is a 2, 1 and minus 3 upon 8, 1 and 2 with respect to del f by del x, del f by del y and del f by del z value at a point P. Or we write as a x minus 2 upon 8 equal to y minus 1 upon 1 equal to z plus 3 upon 2 equal to t. So we get x equal to 8t plus 2, y equal to t plus 1 and z equal to 2t minus 3 is a normal line for this equation, which are the parametric equation of the normal line. Find the equation of the tangent plane and normal line to the surface z equal to 2x square plus y square with point 1, 1 and 3. Now what is our function? Function is z 2x square plus y square. So we are taking 2x square plus y square minus z and point is 1, 1, 3. What is del f by del x? It is 4x. Del f by del y? It is 2y. Del f by del z? It is minus 1. Put the value of p 1, 1 and 3, we get del f by del x at a point P 4, del f by del y at a point P is 2, del f by del z at a point P is minus 1. Equation of the tangent line, x minus x0, del f by del x at a point P plus y minus y0, del f by del y at a point P plus z minus z0, del f by del z at a point P. Put all value of the x0, y0 and z0 and del f by del x, del f by del y and del f by del z in the equation. So we get 4x minus 4 plus 2y minus 2 minus z plus 3 and solve this equation. We get 4x plus 2y minus z equal to 3 is a tangent plane for that equation. The equation of the normal line is given by x minus x0 upon del f by del x at a point P equal to y minus y0 upon del f by del y at a point P equal to z minus z0 upon del f by del z at a point P. So x minus 1 upon 4 equal to y minus 1 equal to 2 and z minus 3 upon minus 1. Again we take the example, show the surface z equal to xy minus 2 and the function x square plus y square z square equal to 3 have the same tangent plane at the point 1, 1 and minus 2. Now let's start the solution. We are taking surface f equal to xy minus 2 minus z and point taking 1, 1 and minus 1. So first we differentiate del f by del x, we get y. At a point P of answer of del f by del x it is 1. Del f by del y it is x. So at a point P answer is 1. Del f by del z it is minus 1. So answer is minus 1. Put all these values in the equation of the tangent plane. We get x minus x0 del f by del x at a point P plus y minus y0 del f by del y at a point P plus z minus z0 del f by del z at a point P. Okay, what is x0, y0, z0? It is 1, 1 and minus 1. Put all the values in the equation. We get x plus y minus z minus v equal to 0. We are taking 3 right hand side. So we get x plus y minus z equal to 3 is a tangent plane of the equation z equal to xy minus 2. Now we are taking the function x square plus y square plus z square minus 3 and taking point 1, 1 and minus 1. What is our first process? We take del f by del x. It is 2x. At a point P, value is 2. Del f by del y, it is 2y. So, value of the point, it is 2. Del f by del z equal to 2z. Then, del f by del z at a point P is minus 2. Put all values in the equation. What is equation? X minus x0 del f by del x at a point P plus y minus y0 del f by del y at a point P plus z minus z0 del f by del z at a point P equal to 0. We put values and getting the 2x minus 2 plus 2y minus 2 minus 2z minus 2 equal to 0. So what is our equation? It is 2x plus 2y minus 2z minus 6. Taking 2 common, so get x plus y minus z equal to 3. Hence, prove that both our functions, both our surface has same tangent plane. Okay. Now, show the plane 4x minus 6y minus z plus 14 equal to 0. Touch the surface x square plus 3y square plus 2z equal to 0 and find the point of contact. Let's start. F equal to x square plus 3y square plus 2z. What is del f by del x? 2x. Del f by del y 6y. Del f by del z 2. Now point is x0, y0, z0 be a point of the surface. So we get 2x0, 6y0 and 2. Put the equation in the tangent plane. We get x minus x0 del f by del x at a P 5 minus y 0, del f by del y at a point P, z minus z 0, del f by del z at a point P. Put all the values, then we get x0 minus x0 whole square plus 3y0 minus 3y0 square plus z minus z0. So we get x0 plus 3y0 plus z0 equal to 0. Now x0 plus 3y0 plus z0 equal to 0. Comparing with the plane 4x minus 6y minus z plus 14 equal to 0. We get x0 upon 4, 3y0 upon minus 6, 1 upon minus 1 and z0 upon 14. So x0 is a minus 4, y0 is a 2, z0 equal to minus 14. The point minus 4 to minus 14 satisfy the equation of surface and the tangent plane. Hence the point of contact is minus 4, 2 and minus 14. Some examples here listed to do yourself. To try to find the tangent plane and normal line to any surface using today's lecture method.